Hey guys, it's Mr. Cottrell. Going to be working today on lesson number 14, dividing decimals with a remainder using place value understanding, and then relating it to a written model. The first couple that we're going to do, I'm going to be honest with you, take a little bit more time, but then we're going to show you another easier way that we can also do it, and you're going to choose which one works best for you. If you're following along in the book, we're on page 67 and 68 in your textbook. Okay, page 67 and 68. Okay, number one, we're going to take the number 4 and 236 thousandths, and we're going to divide it by 3. If you notice on your place value chart, they divided it up into, at the bottom, 3 different pieces. And you're going to see how that's helpful in a minute. Okay, 4 in the ones place. 1, 2, 3, 4. 2 in the tens place. 1, 2. 3 in the hundredths place. 1, 2, 3. 6 in the thousands place. 1, 2, 3, 4, 5, 6. Okay, now we're going to divide that by the number 3. If we divide it by the number 3, I can put 1, 1, 1. I have 1 left. I cannot take that 1 disk that's left. So I've got to move it over to the tenths place. When I move it over to the tenths place, that's the same as 10 disks, remember? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we've got to group these into 3. So I've got 1, 2, 3, 1, 2, 3, 1, 2, 3. One, 2, 3. And there's none left. So we're okay on that one. Next one, 3 in the hundredths. 1, 2, 3. And then thousands. 1, 2. We're breaking them up into 3 even parts. Okay. Now when we're looking at it, we only want to look at one of the lines. We only want to look at one of the lines. So when we look at just one of them, we have 1 and 4 tenths, 100th, 2 thousandths. Second way we can do it is using the standard algorithm. 3 goes into 4 once. We have 3, subtract, bring down. Remember to put your decimal point. Same place, does not move. 3 goes into 12 4 times. 4 times 3 is 12. Subtract, bring down. 3 goes into 3 once. 3 times 1 is 3. Subtract, bring down. 3 goes into 6 twice, which is 6, which leaves us, when we subtract, with nothing. Same answer, 2 different ways that we can do it. Okay, number 2. We've got a 1 in the ones place, so we're going to put 1 disk. 3 in the tenths, 3 disks. 2 in the hundredths, 2 disks. 4 in the thousandths, 4 disks. And on this one, we're dividing by 2, so we split up our chart into 2 different columns at the bottom. 1, you cannot divide that by 2. We can't put 1 evenly in a 2. So we're going to cross that out, move it over, and we got to add 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we're going to evenly put those in. So we've got 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. We're left with 1. You can't put it on either one. You need whole chips. So that's going to move over, give us 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you don't want to cross them out and do 1 and 1 and 1 and the other, you could say I got 5, then I have another 5, and 2 gives me 12, which means I know that I'm going to have 6 in one and 6 in the other. Last one, we've got 4. If I want to split 4 into 2 equals, that's 2 and 2. I'm going to have 2 here and 2 here. Going to go back. We had nothing in the ones place. We have a decimal point. Only looking at one of them. Don't look at both. 1, 2, 3, 4, 5. We have 6 tenths. 1, 2, 3, 4, 5, 6 hundredths. And 2 thousandths. Standard algorithm. 2 cannot go into 1. Add your decimal point. Goes in the same place. Bring down the 1. Bring down the 3. 2 can go into 13 6 times, which gives me 12. When I subtract, I get 1. Bring down the 2. 2 goes into 12 6 times, gives me 12. Subtract, I'm left with nothing. I bring down my 4. 2 goes into 4 twice. 2 times 2 is 4. Subtract, left with nothing. My answers match. I got the same answer for both of them, so I know I'm on the right track. Okay, number 2, we are going to solve using just the standard algorithm. You don't need to do the chips. So on the first one, we're going to have 3 goes into 78 hundredths. 3 does not go into 0, so we put a 0. 0. Bring down the 7. 3 goes into 7 twice, which gives me 6. Subtract, we have a 1. Bring down the 8. 3 goes into 18 6 times. 18, I subtract. There's my answer, 26 hundredths. Number 2, the first number in division is going to go in the house. And we're going to divide that number by 4. 4 can go into 7 one time. When I subtract, I'm going to get 3. Bring down the 2. 4 can go into 32 8 times, which is 32. Subtract. Bring down the 8. 4 can go into 8 twice, which is 8. Subtract, and I'm all done. Almost. Don't forget your decimal point. 1 and 82 hundredths is going to be the answer. Our third one, or letter C, we're going to take 17 and 45 hundredths. And we want to divide that in groups of 5. 5 cannot go into 1. 5 times 0 is 0. Subtract. Bring down the 7. 5 goes into 17 3 times, gives me 15. 2. Bring down the 4. 5 times 4 is 20. Subtract. We have 4. Bring down the 5. 9 times 5 is 45. Subtract. And I'm all done. Don't forget your decimal point goes in. So I have 3 and 49 hundredths. Not too bad so far, right, guys? Okay, the next one. Grayson wrote 1 and 47 hundredths divided by 7 equals 2 and 1/10 in her math journal. Words, numbers, or pictures to explain why Grayson's thinking is correct. Okay, picture first. Ones, decimal point, tenths, hundredths. She's got a 1 in the ones place, a 4 in the tenths place, and a 7 in the sevenths place, 7 in the hundredths place, not a 7 in the seventh place. Get it together, Mr. Cottrell. Jeez. Okay, we now need, this one's a little bit harder. We got to split it into 7. So here's 1, 2, 3, 4, 5, 6, 7. 1 cannot evenly split it, so that becomes 10 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10, 11, 12, 13, 14. That means if I have 7, each one's going to get 2. Because if I divide 14 by 7, it's going to be 2 in each one. Use those all up. Now I'm going to go to my hundredths. I've got 1, 2, 3, 4, 5, 6, 7. That means each one's going to get 1 if I divide 7 by 7, which means my answer is going to be decimal point 21. To check it, we're going to do standard algorithm. 7 cannot go into 1. Subtract, bring down. 7 goes into 14 twice. Subtract, bring down. 7 goes into 7 once. Subtract, and we're done. Don't forget your decimal point goes just right up on top. 21 hundredths. So Grayson was wrong. I do like his name, but he was wrong. Okay, Mr. Nguyen used 1 and 48 hundredths meters of netting to make 4 identical mini hockey goals. How much netting did she use per goal? So I'm going to go with 1 and 48 hundredths, and we want to divide that netting up into the 4 goals. 4 does not go into 1. 4 goes into 14 3 times, 12. 4 goes into 8 7 times. And when I subtract, I'm done now. Don't forget my decimal point, it just goes up. So each goal uses 37 meters of netting. Last one for today. Oh, look, Esperanza. We're reading about her, and now she's in math class. Esperanza usually buys avocados for 94 cents a piece. During a sale, she gets 5 avocados for $4.10. How much money did she save per avocado? So normally they're 94 cents, but now she can get 5 of them for $4.10. 5 does not go into 4. Bring down the 1. Made a mistake. Got to bring down the 4. 5 goes into 41 8 times. 8 times 5 is 40. Subtract, we're left with 1. Bring down the 0. That is a 2, which gives me 10. And we're left with nothing. Put our decimal point in. So avocados are 82. We want to know how much she saved. So we're going to take 94 cents. And then we're going to take 82 cents. Line up those decimal points when we subtract decimals. 4 minus 2 is 2. 9 minus 8 is 1. So we know that Esperanza saves 12 cents per avocado. Have a good night, guys.